complete the lab in class today. This lab is called Get a Half-Life. All right, so you should have read the Sitch at home yesterday. So we have an element that's in the school food called cosmic cubicium, and we have been tasked to determine the decay rate or the half-life of this new element that has contaminated our food. We need to know how long that's going to take. So we're going to make a model. All right, so this is our model. All right, so the element is called cosmic cubicium, because this is the element right here. These are models of atoms of this element. And the first thing that you need to do is to count the number of cc's that you have in your cup. All right, you're going to count the number of cc's in your cup. Let's just say I have 41 cc's. I'm not going to take the time to count them, but you will. All right. So after you count your cc's, you're going to dump them into the bin. All right. And what you're going to do is you're going to do what we call shakes. It's kind of like trials. Okay. So we're starting off with 41 cc's, 0 beans, for a total number of cc's and beans of 41. So in case you haven't guessed it by now, the cc's are the parent radioactive element and the beans are the stable daughter element. All right. So when we say number of shakes, what we really mean is like number of trials. I don't mean that on trial 1 you're going to do 1 shake and on trial 2 you're going to do 2 shakes. No, that's not what I mean. So the way that you're going to make this element decay is that you're going to take the lid, okay, and the lids are have seen better days. They probably have cracks in them. You don't have to put the lid on, all right, because then every time you have to take it off and that's what happens, they crack. So all you have to do is like place the lid here and then pick it up and hold it down with your thumbs. And when I say shakes, I mean this, right? Okay, so that's a shake. You're going to tussle the cc's, okay? Now, the ones that have decayed are the ones that show the red dot. So how many have decayed? 1, 2, 3, 4, 5, 6. So we're going to take those 6 out. Okay, we're going to take those 6 out. 3, 4, 5, and 6. Okay. Now, how many cc's do we have left in the bin? Well, 41 minus 6 is, oh, by the way, you're not writing this down. I'm just modeling what you're going to be doing. 41 minus 6 is, 41 minus 6 is 35. So we lost 6 cc's. Well, what did they get replaced with? They got replaced with the stable daughter product. So how many beans are we going to add? We're going to add 6. 1, 2, 3, 4, 5, 6. Okay. And that was number 1. Every time you do this, we added 6 beans. So 35 plus 6 is equal to 41. That's what you're going to do. All right. You're going to keep putting the lid on and you're going to keep shaking them. Okay. And every time you're going to take out the ones that have the red dot up and you're going to replace them with beans and you're going to record your data here. Now, I have given you 21 shakes, okay? You're not going to actually use all 21 probably. Like one group, maybe you'll only use 17, and another group, hey, maybe you'll use 19, and another group might use 16. Who knows? Okay, they're here if you need them. Okay, now, when you get to the end, and there's only like maybe 3 left, they could be really stubborn. They might not want to flip. If you have like 3 left, feel free to do like 3, 2, 1, 0, and then just replace them with beans. Because what you don't want to happen is you don't want to have like a flat line on your graph when you make it. Okay, so once you get down here and they're being stubborn, just do one at a time, and that's okay. All right. Again, the number of shakes is the number of times it takes for you to put the lid on, do that, and see how many decay. All right. So when you're done, you're going to put your cc's back in the cup. You're going to put your beans back in the other cup. You're going to put the cups back in the bin, put the lid on the bin, and put it back in the back of the room. Okay. And then you're going to do step number 5. So we did step 1, 2, 3, and 4. Okay. Step 5 is plot the number of shakes versus the number of cc's / number of beans on a graph and draw the smooth curves, which is a line of best fit, connecting the points. Now, when I say connecting the points, I don't mean that we're going to connect the points. We're going to draw a nice smooth curve, okay? You're going to have one B line and one CC line, so you're going to make a double line graph, and you're going to do it in landscape format. So when you're done, your teacher will give you a piece of graph paper. It's at the front there, okay? And the independent variable always goes on the x-axis, so the independent variable is what you controlled, which is the number of shakes, okay? And then the dependent variable is the data that you collected, and the number of cc's / number of beans is the data that you collected, all right? Now, not all graphs have this, but this graph does. You are starting with 0 shakes, and you're ending with 0 cc's, and you started with 0 beans. So there is a 0, 0 for your origin. All right. Now, I'm not going to say that you have to use all of the graph space, but you do have to use the majority of the graph space. So depending upon your number of shakes, well, maybe it's two boxes is worth a shake. Or maybe if you had fewer shakes, maybe 3 boxes is worth a shake. Okay. What I do know is that over here, 1, 2, 3, 4, 5, I do that over here that each box is going to be worth 1 for the number of cc's, number of beans. Okay. If for some reason you had more than 40 cc's in your cup, just estimate where the first plot point is going to be. I don't know why. Sometimes you should only have 40, but sometimes people have more than 40. Okay. Maximize your graph space. And what's going to happen is maybe you're going to have plot points that look like this. 1, 2, 3. So up here, and 1, 2, 3. Down there. Do you see how they're not? It's kind of not in a line. Okay, so if I was to draw a line of best fit here, this is kind of like a little outlier. It's not going to be a point-to-point line. It's going to be a line of best fit. Okay, so when you're making a line of best fit, you want kind of half the data above and like half the data below your best fit line. Okay, it's a smooth curve, not a point-to-point line. You guys may have called it a trend line when you were learning this, except it's a curved trend line, not a straight trend line. So again, it's not a point-to-point line. Okay. So plot your CC data, plot your bean data, make a graph, a double line graph. Where the 2 lines meet is your length of a half-life, okay? So that's what you're going to be doing in class today, all right? We will go over it tomorrow. Everyone have a good day. Thank you.